Good morning. Welcome to our presentation on steep slope commercial roofs and making them watertight. This morning, we are your presenters. I am Jimmy Akins. I'm the National Technical Manager. My esteemed colleagues here are Marco Sieber. He's our North American Product Manager of Roof Membranes. And we have Steve Wadding, RRC, RRO, CDT, and any other initials that you need after that. He's our Corporate Project Managers. Today we'll be talking to you basically about the use and the primary design characteristics of underlayments. Many commercial building roofs today incorporate steep slope roof designs. Although the slope and the roof covering aid in shedding water, specifiers and contractors must make challenging choices on how to ensure water tightness of the roof assembly. In this presentation, we'll show you how water tightness can be achieved when using popular roof coverings through metal, tile, shingles, etc., through proper roof design, selection of secondary water barriers, for example, the water underlayments, and installation techniques. Our learning objectives today will be understand the critical factors that can lead to the leaks in a steep slope roofing system, identify installation and design as well as product solutions which can reduce the likelihood of water intrusion into your structure. We will understand the role of secondary water barriers and compatibility of underlayments with intended roof coverings a little bit better. We'll explain how building codes and regional considerations can affect the selection of such underlayments and secondary water barriers. Roof systems shed water, but why can they still leak? Various reasons. We've all seen them happen. We've seen water go uphill. We've seen them intrude through any creeks or previously open. They can be created by fasteners, through roof penetrations, insufficient roof assembly design, inaccurate installation techniques, roof covering, and the selection of your underlayment and secondary water barriers. Where can they leak? Very commonly with roof tiles, your concrete and clay tiles, broken tiles or tile blow-offs can cause leaks. Again, the nails and flashing details are always consequential. With your asphalt shingles, we see shingle damage from blow-offs, from nail, from hail, and again, from our flashing and details. Architectural roof metal panels, also metal panels blow off. You have fasteners work themselves loose, seams break loose, and again, the flashing and details. I want to show you an example of this picture, too, why it's critical to select the right products for underneath certain applications. When picking a metal product for your roof surface system, you want to have a system underneath of your waterproofing that it also works friendly with the metal, where the metal will not be stuck to the subsequent application. You can see here you had a little bit of asphalt bleed through on this product, and it helped hold the tile in place. So when you got your bellying or your expanding and contraction between your hot and warm climates, it also increased the product's decreased its survival rate. Why can they leak? Well, selection underlayments based on minimum of codes. Beware of using minimum code requirements on an only basis of selection. Consider life of the roof covering during underlayment selection. Improper selection based on product conditions. Roof design and covering and local weather are key considerations. Deficient installation practices. Again, flashing penetrations, skylights, chimneys, etc. Exceeding product exposure ratings. As we know, a lot of these products can only sit out in the sun so long. Your roof edge, your eave details, side lap, end laps, and your improper fastener and proper fastener placements. Steep slope roof design options to reduce water infiltration. Roof design by minimum code, as we know, can be sometimes can be a hairy slope. A lot of times we'll look at products, we'll select our products on our design, and we'll look at the basic minimum codes to meet those. A lot of times regional weather plays into effect, and that's not necessarily the case. You don't want to follow just the minimum code. You want to meet or exceed. Generally, with a steeper pitch slope, 6 and 12 works better for your snow conditions. In the more temperate zones, the lower pitch of 6 and 12 and lower works well because it reduces the cost of truss systems, provides visibility of the roof surface, and will also work in shedding water. Ensures the roof covering choice is suitable for your roof building slope. Asphalt shingles are not recommended for slopes less than 2 and 12. Tile minimum slope is 412, using a waterproofing underlayment under the tile roofs. Metal minimum slope varies by type, architectural versus seamed or structural panels. Roof assembly design is ideal for the climate. When we're tightening up our roof details, obviously we want to make sure we're taking care of our penetrations. The roof covering and the related materials are also critical to performance related to the exposure elements such as wind, rain, and hail. Slope transition and pitch changes, these must work to shed water from the roof without washing under the roof surfaces. Many times the water volume can increase due to the amount of rainfall within a certain time period and cause that rush of water up underneath your improper metal applications, primarily at the drip edge and your metal applications around such edges. Your roof-to-wall flashings, your interfaces with your roof coverings to wall locations is also a source of water intrusion. Utilizing proper details and secondary water barriers is very vital to the success in these applications. And again, your roof and drip edge. If you're unsure of your drip edge details, provide a means for water service to flow freely from the roof, making sure our water exits at a decent volume rate, not to cause other substantial damages. When we're tightening up our roof details, it's very important to pay attention because proper design and product choice is critical to valley locations, as these are a common source of water intrusion. Your hips and ridges are subject to greater wind effects, so use of enhanced techniques and product choice is very important. A lot of times you'll see a lot of enhanced applications through mechanical fastening or the use of secondary bonding adhesives. Your eaves and overhangs are advantageous to many of the designs, but they do add a greater exposure to wind and driving rain. So we want to remember those considerations as we're laying out and planning our roof systems. So the use of secondary water barriers. Secondary water membranes are ideally suited for nearly all roof coverings. These are advantageous to most roof designs and are required in some climate locations by code. Use of secondary water barrier as part of the roof assembly, even when not a code requirement, at the details such as the roof edge, your roof penetrations, and roof-to-wall conditions offer greater building protection. In the event of wind or other physical damage to roof coverings, the secondary water barrier offers a barrier to prevent water migration into the building's interior. The climates of ice and snow or other severe weather, secondary water barriers are strategic and vulnerable locations or even the entire roof deck to prevent damage to the building's components, its interior, and to prevent substantial long-term damages. With that said, I would like to turn it over to Mr. Steve Wadding to discuss the climate, building codes, and other regional considerations for your design aspects.
Good morning, everybody. As you can tell, there's going the main part of this presentation is we're talking about underlayments as a whole, because everybody tends to get stuck on the fact, well, you shove a roof covering on a steep slope and it just works. Well, and that can be true to some degree, but underlayments do play a critical part for various reasons. And as you can tell, we're going to touch on secondary water barriers. Are you guys familiar with using secondary water barriers? And there's not a lot of areas in Texas that are required because, I mean, typically, secondary water barriers are kind of a new idea. The International Home Builders Association, IBHS, the insurance guys, they are pushing their Fortified program, if you guys have heard of that. They are pushing the element of doing secondary water barriers. And you can incorporate that, as an entirety or various aspects. So you're going to hear a little bit about that, if you will, as we go through this. A big reason to consider secondary water barriers is related ice damming. There are some areas in Texas that you're going to have, and throughout the climate zones 5, 6, and 7, you're not going to see a lot of it in 4 and below for the most part. It'll be an unusual condition. But ice damming is a real condition that creates a lot of damage in a lot of areas, especially in roof coverings that have, because most of our steep slopes, they're not interlocking systems. They either just overlap, they may be semi-interlocking to some degree, but most of them are not sealed and locking systems, say such as a metal panel that's got a mechanically rolled seam. Now that's a totally interlocking system. But ice damming can cause some real damage in the event when it starts to occur. Now, if you're using traditional underlayments, they do serve as a barrier to the sheathing, But when ice damming starts to occur, they're not typically sealed. They're not typically sealed to the metal. Everything is just overlapping. So ice damming can really come back as the warm air from the attic comes up, freezes, or if you will, freezes the water on the surface. It freezes and refreezes, and when it literally just creeps right under the roof covering and underneath the underlayment, creating years of damage to the eave areas and soffits. When you start using self-adhesive underlayments, for example, or an ice barrier, say on your typical code, which is 24 inches inside the outside wall, that prevents that damage, because rarely are you going to see ice damming come more than 24 inches upslope to a roof. Typically, ice dams are required on areas where the average January mean temperature is 25 degrees or less. That's just kind of upper. I live in Reno, Nevada, for example, and you would think as much snow as we get in that area that ice damming would actually be required by code, and it actually is not, because we're about 2 degrees off that mean January of 25 degrees. As strange as that sounds. Talk about wind and wind-driven rain. That's another big issue when it comes to damage, and where secondary water barriers and heavier underlayments really become a factor. Okay. Now, you heard Jimmy mention about building codes. Building codes often are seen as that's the maximum I got to do. In reality, building code should always be reviewed as a minimum standard, especially on our roof side, because building officials don't get heavily involved in over-criticizing building code issues on roofing. As you can tell, our underlayments are just pretty standardized. We've used them for years. In fact, metal years back went from a number 40 requirement back to a number 30. So sometimes building codes actually wind up going backwards. So you want to keep in mind the fact that a building code requirement should always be looked at as a minimum, and it's, in some places exceeding that is going to be a benefit to not only the customer you're doing work for, but also to yourself, because then you're not creating with callbacks and you're not going back trying to figure out something that's a problem. As it relates to wind, the idea of you having good underlayment underneath there, even if you would lose part of the roof covering, at least you're going to have some barrier there. In severe events, we've all seen, hurricanes, tornadoes, if you're losing your roof covering, microbursts, which are not uncommon in this neck of the woods, with an underlayment there, at least you got some protection. And it really helps when you start looking at, say if you're using organic underlayment, say if you're using a secondary water barrier, such as strips of a self-adhesive over the plywood joints, at least if you would lose your roof covering and maybe lose part of your underlayment, the theory is at least you'll keep the damage to the inside of the building at bare minimum. So even if the job wouldn't afford you the opportunity to use a self-adhesive underlayment over the whole building, at least you could use it on the joints in the structural deck. Wind-driven rain is, especially Florida and southeast contractors in general see just the impacts that wind-driven rain can be, because when the wind starts blowing and the rain starts blowing, wind starts going heavy, it can literally blow, near horizontal. And, that can be detrimental when it comes to certain roof coverings and things like shingles, water get underneath, architectural metal that just have, clips over the seams. That stuff can get underneath those roof coverings. That's why the underlayment use is important, and then considering maybe enhancing that is a plus. Look at, these drawings are kind of simplest, but it kind of gives you the idea of why getting a good underlayment underneath the roof covering is an important idea, because when wind-driven rain starts to occur, it can literally drive underneath an asphalt shingle or other roof covering types, concrete tile, etc., and it's going to migrate under the roof covering, and depending on the design, concrete tile and battens, that tends to hold a fair amount of water. So it takes a while for it to migrate off, and if the underlayment's not a sufficient type or installed well, you're going to have problems, and you're going to have water migrating down through the fasteners, holding various things down. A secondary water barrier has various elements of fastener sealability as you're penetrating through, so you don't get that same condition of water migrating into the structure itself. Some of the guys in the Southwest, have this mentality, why do I even need an underlayment? Because it just doesn't rain much in the Southwest, Southern California, Southern Arizona. It does rain, but it's not as frequent. You don't see the elements that you do in climate zones that are beyond, say, 3 and higher in the country. But underlayments are still important because they play an integral part of any roof covering. There's no roof covering that doesn't require an underlayment. Now, it could be because of how the underlayment works. It's really important with concrete clay tile because they just are overlapping systems. Still important even with asphalt shingles. Even Canada finally did away with their not requiring an underlayment underneath shingles. They had that for decades, and they finally realized the fact that they needed to require an underlayment underneath the shingles because they had a lot of snow issues that were drifting into attic spaces. So underlayments are required regardless, and it's important because they can be tied to various product approvals, even on the fire side, because as the assembly is tested a certain way, all those components of that assembly are required. So if they're using some particular components, particular underlayments or whatnot, you'll see that those are important. Example, things like, VersaShield, for example, that some of those are in product approvals for other roof covering products that require as a fire barrier. There are other companies that are making underlayments that have some fireproofing characteristics that will help. And they've been tested with various things, so it's something to look at and keep in mind when you're using certain roof coverings. Storm damage, occurs even in drier climates. Monsoon season, microbursts. That stuff happens, and it easily can affect the roof covering. So the presence of underlayment is required, and it's important and can enhance the whole assembly. Just keep in mind that every 3 years the building code changes, but in reality, I think I want to say the statistic is only 16 states in the U.S. have even gone as far as adopted the 2016 building code. All states besides that are using older building codes, so it can be important to check with the building official and say, well, what are we signatory to, so you know what to look for to make sure that you're complying with whatever the code is. And a lot of building departments or a lot of cities, states, whatever, will adopt a code, but they'll modify it to what they want. So you'll see a lot of very regional specific alterations to building code. Talk about hail for a second. Hail's a big to-do with certain roof coverings. Not only aesthetically, but the impact can do significant damage. Steep slope products are tested for hail. Typically most manufacturers do UL's 2218. Steel ball, drop through a 20-foot tube, comes down, and impacts. And depending on the size of the steel ball used, whether it's 3/4 of an inch, 1 inch, 2 inch, that will determine the rating that the product will get. Most things you see nowadays, like shingles that are severe hail, that's a 2-inch ball. And you think about a 2-inch steel ball drop 20 feet, that's pretty significant. That's a pretty good resistance when you think about it. The new thing that you'll probably see in the near future will be the very severe hail coming up, which is going to create some different challenges. And there's also a lot of talk about implementing realistic, what they'll call ice ball projections, to do actual projections of ice balls. Some of the insurance companies are really starting to invest to develop a realistic ice ball. So you see that as a kind of an upcoming thing. So I would keep your eyes on that, because you may see that come about in the future code. The thing that's important to keep in mind, I guess, when you're talking, especially when you're talking about hail, these are laboratory tests, and it's meant to see a minimum level of performance, and it's meant to compare products to products under the exact repeatable conditions. Just because something passes severe hail at a 2-inch ball doesn't mean if you get a 2-inch real hail pellet in any condition that it potentially wouldn't damage a roof covering, because it's possible. Because angle, the roughness of a real hailstone, etc., temperature, because usually when it starts to hail, the temperatures drop very, very quickly, and then you get that energy along with the colder temperatures can have an impact on certain roof coverings. So it's something to keep in mind. It's not an assurance that 1-inch hail wouldn't damage it, even if it's rated for severe, but It's just to compare products. So just you kind of got to keep that in mind. Talk about codes for a second, okay? Now, pretty much any product you're going to see in the markets, with a few exceptions that I can think of any major manufacturer is going to be, have been tested for hail, and that's pretty clearly outlined. Now, there are some elements that will have specific requirements. So you need to, and you'll hear the term authority having jurisdiction. So whatever city, county, state, whatever the case may be, you need to double check with that authority having jurisdiction to see what severity they require. Especially the most unusual part is on the residential side, especially single family. Building codes and ratings for those type of structures can be all over the place. Some aren't even classified. So there's no requirement for fire or hail or anything. They're just unclassified. So you just want to be sure of the fact that there's not something strange going on. And if you say you're doing work in an area that you're unfamiliar with, that they don't have some particular weird code. An example, in Florida, Charlotte County is kind of up there in the middle of nowhere, and for years that building official up there just comes across with the most bizarre stuff at times, depending on what he wants. He'll suddenly want something from a hurricane zone here where it's not required by Florida's Constitution, but you just need to make sure that you know what you're dealing with, so you don't get in a contract, get a job done, and then find out something weird goes on. The role of the underlayment's critical. Here, for example, here in Texas, hail damage, say damages product to some degree, and if it's not noticed for years, you could get some saturation through that roof covering because the compound was compromised or something. If there's no underlayment underneath there and it's not in good shape, you could wind up having leaks in the building. So you really want to make, they can't stress enough. It's really important to make sure that when you're looking at the underlayment, that it's serving a bigger function than just keeping the wood tight until you put a roof covering on. Talking about fire, everybody's favorite fire. Now, typically, I'm not aware of, and somebody could raise their hand if they're familiar, I'm not aware of any structure fire, even in urban wildlife, that was a result of embers flying onto a roof other than a wood shake shingle, and that's even been years ago, that actually started a structure fire and burned a structure down. Typically, flying embers are more of a result of flying embers hitting the side of the house, up underneath the eave, that type of thing. But fire ratings are still required on all roof coverings that we do, and having underlayments as part of that assembly are a requirement. Okay? And specialty underlayments, you put those with various roof coverings, and those can often be used in an exchange to increase the underlayment on any assembly that most manufacturers have. Now, Class A being the most severe, the boring part, that's a 6-foot spread of flame, and then that's penetration and burning brand, which those are just done for combustible wood ducts. But those are pretty severe. If you've never seen a video of a UL 790 fire test, the burning brand especially is pretty severe. You got a big 2-foot by 2-foot, 3-story or 3-layer hardwood that's being lit on fire, and then you're setting it right on top of the deck and then blowing a 12-mile-an-hour wind at it on and off for 20 minutes. And then the second part of the test, you set it on there until it completely burns away. That's pretty severe, you think about, for a roof covering. When do roofs get exposed to that kind of exposure? They don't. And a lot of common misconception is that metal roofs don't burn and they're automatically Class A fire tested, and that's not true. Most metal products, unless there's provisions made, are Class B rated. So that brand is only 1 foot versus 2 foot, and they still require underlayments underneath them. Okay, but there are a lot of options that not only improve the waterproofing resistance, but also the fire resistance of roof coverings, even metal. Kind of to that point, there are products that can enhance not only and take a roof covering that may not have a Class A fire rating and enhance it so it can pass the Class A testing, but it also provides, if you will, increasing the fire rating, but also provides a whole weatherproofing over the whole deck. So should, again, that roof covering be lost in any section, you're not going to get any water in the structure. And from an insurance perspective, I mean, that's the one thing that's the biggest thing that they complain about is water damage is usually greater than that of the damage of a storm when it comes to related to exterior damage on the building so often as the case is. Because burning embers can penetrate a lot of various products because they're not sealed. Most of everything on a steep slope is overlapping. It's not airtight, therefore it's not watertight, therefore it's not completely tight to things like small flying embers. The picture kind of is just kind of giving you an idea. If you put a full self-adhesive underlayment that's manufactured specifically to enhance these two characteristics, you put the roof covering on, and then you really don't have any worries in the future about how the system's going to perform. You can lose part or all of your roof covering, and your customer's roof, your client's roof, is still protected from water intrusion. Okay, I'm going to pass this off to Marco, and he's going to kind of bring the last portion of this home.
Thanks, Steve. Good morning, everybody. In this section, I'll be reviewing roof covering and underlayment installation best practices to limit or reduce roof leaks. So regardless of the roof type that you're using, tile, shingle, metal, there are some basic principles that you can follow on all those roofing types to limit significantly the probability of roof leaks. And those best practices have a lot to do or vary due to climate conditions, where you are located geographically, and the desired performance that you're seeking from your roof, how long you want it to last and under which conditions. Install roofing products that are rated for local wind zone and local specific code requirements. Seal the roof deck using an underlayment system that's suitable to the climate and the roof covering type you're using. Install drip edges at eaves and rakes and flashings and roof penetrations and wall intersections. And for those roof coverings that are mechanically attached, like a metal roof or a shingle roof or some types of tile roofs, a polymer modified self-adhered underlayment, the properties of it can help fasten around those different fasteners, be it nails or different fastener types. So those are just some kind of general principles to follow that apply to all roof covering types. Now we'll go into some specifics. With concrete or clay tile roofs, I mean, these are pretty robust roof coverings, but they do crack and they're not immune to roof blow-offs and severe wind events. So we do recommend sealing the roof deck using an underlayment system that's suitable for the climate. And just like the other principles that I mentioned, drip edges, eaves, and rakes, and install flashing at roof penetrations and wall intersections is key. And as Steve was saying, choose roof covering types that are rated for local wind zone and local specific code requirements, including weather events such as hail if you're in a hail-prone area. Now, for asphalt shingles, also there are hail-resistant asphalt shingles out there. So if you're in a hail zone, you want to make sure you select one for hail and wind-borne debris, and install shingles in accordance with manufacturer's instructions. But for high wind locations, you have to take extra precautions, such as using 6 nails per shingle, not using staples, and properly locating the nails within the nailing zone of the shingles so that you nail not only the shingle that you're fastening, but also the shingle below it at the same time. In coastal regions, you have to be careful with your fasteners. You're using hot dip galvanized or stainless steel fasteners when the building is located close to coastal areas with salt water. And driving nails properly. That applies to all these roof covering systems. Do not underdrive, overdrive fasteners, or fasten at an angle. For asphalt shingles, also applying bands of asphalt roof cement in critical areas enhances the shingle securement, such as in the eaves. And seal the roof deck with an underlayment system suitable for your climate. In climates where you have high snow loads, using a self-adhered bituminous membrane along those roof eaves and other critical areas like valleys and rakes is critical and sometimes mandated by code. So you seal those critical areas from ice damming conditions. For metal roofing, we also recommended sealing the roof deck but using a high-temp underlayment system, and we'll cover what high-temp means here in the next section. Most standing seam roof systems have minimum slopes 2 and 12, so make sure that your underlayment and your roof system is adequate for that minimum slope. Corrosion-resistant metal panels in coastal regions are key, and install the metal roof panels in a manner that avoids puddling or water being trapped in the seams so that water can flow freely to the gutters. With metal roof systems, you have to be conscious of something called galvanic corrosion, which is corrosion that's caused when two dissimilar metals come into contact with each other. For example, you're using a hot-dip galvanized nail in a copper metal roof system. You can have some accelerated corrosion in doing that. So you have to be careful with that to have compatibility between fasteners, clips, and the metal panels themselves. Fasteners should display an equivalent corrosion resistance to material fastened into. Basically, you want fasteners and clips that will last as long as your metal panel system. And don't underdrive or overdrive the fasteners. With metal panel systems where you're using a rubber washer, if you overdrive it, it might break that washer, so you have to be careful of doing that. And fasteners should not be driven at an angle. So we just covered best practices for different roof coverings. And this section we'll talk about underlayment specifically. Now, this varies a lot according to regional considerations and local code requirements, but these best practices for underlayments are for actually sealing the roof deck specifically. When you seal the roof deck, it's proven to reduce significantly the amount of damage that can be caused in the event where your roof covering is damaged or blown off completely. Why? Because water is much more difficult for the water to penetrate through the roof deck joints if the deck is actually sealed. So your first option is to use a polymer-modified self-adhered membrane over the entire roof deck. Your second option is to install a 4-inch wide self-adhered flashing tape over the roof deck joints and go over that with a 30-pound felt or an equivalent synthetic underlayment. And your third option is to install 2 layers of 30-pound felt or equivalent synthetic underlayment with or without the 4-inch self-adhered flashing tape. There are 2 basic categories of underlayments. You have your mechanically attached and your self-adhered. So your mechanically attached underlayments will include your organic felt, synthetic underlayments, and some modified asphalt underlayments. And those are going to be fastened at a rate prescribed typically by the local building code or your project requirements according to wind speed calculations, etc. So, but for situations where you might have an extended exposure period, for example, there's a long lead time for the roof covering and it'll be weeks or months, the roof will be exposed for weeks or months, you might have to give additional precautions to the mechanically attached underlayments. For example, extending the size of the laps so that you have extra protection. And in lower slope conditions, an extra layer of underlayment may be necessary. So the other category of underlayments are your self-adhered, and specifically the polymer-modified bitumen self-adhered underlayment, which has asphalt compound that provides the waterproofing. These types of underlayments are bonded directly to the substrate, which is typically going to be your plywood deck, and it provides a true secondary water barrier in the event of the loss of roof covering or at fasteners or flashings or other critical areas. The self-adhered membrane is also, because they're bonded to the substrate, when you walk on it, when the roofer is actually installing the roofing system, it doesn't really move that much around the fasteners. It does not create an opening around the fastener head, so it actually helps with that versus a mechanically attached system. And these membranes are pressure and temperature sensitive, so after you install it, you have to apply pressure using a weighted roller, such as the one pictured here. And most self-adhered membranes have to be applied at a temperature of 40 degrees and rising and go through up to 3 thermal cycles before reaching full bond strength. And this section will cover compatibility between the roof covering and the underlayment. So, typically you're not going to choose the underlayment first. You're going to choose the roof covering, be it, tile, shingle, or metal, whatever it may be. And then you have to select an underlayment that will work with and be compatible with that roof covering type. So you're looking at functional performance with the roof covering plus zero compatibility issues. And you want to select, ideally, an underlayment that's going to last as long as your roof system, right? The roof covering that's going on top of it. Going into a little bit more specifics about some main roof covering types, with metal underlayments, I talked a little bit earlier about high temp, right? And what does that mean? Well, with metal underlayments, metal has different properties than other roof coverings. It has a different thermal gain loss values. It actually releases radiant heat at a higher rate, absorbs it, and releases at a higher rate than other roof coverings. So if the underlayment is not designed for those high temperatures, you could see a loss in the waterproofing compound underneath and actually dripping of asphalt, which is what you see in the picture here. So if you're losing your asphalt compound because it's dripping out, then you're going to have less waterproofing in that properties in that underlayment. To resolve that situation, you should select a high temp underlayment. And high temp underlayments are usually those that are rated to temperatures above 240 degrees Fahrenheit. There are some metals such as copper that usually operate at even a higher temperature, so sometimes you need an underlayment that's rated higher than 240 degrees. Now, metal, of course, requires a whole series of fasteners and clips that penetrate through the underlayment into the deck. So an underlayment that provides self-healing qualities around those fasteners is very helpful in terms of increasing the performance of your roof system. You also should avoid underlayments with rough surfaces when you talk about metal roofing, so that, for example, a mineral surface underlayment could scratch the finish of the metal. Ideally, a high temp underlayment with a top synthetic film surface is perfect for metal roofs because it's a smooth surface with slip resistance, but it allows a free movement of the panels with expansion and contraction because of temperature differences and without catching on the underlayment. So it's kind of an ideal compatibility there. For concrete and clay tile roofs, you have two forms of installation. You have typically mechanically attached or adhesive set. So you have to choose an underlayment that's compatible with that installation method. With mechanically attached systems, code may permit an organic felt, for example, underlayment. But because it's mechanically attached, polymer modified self-adhered underlayment or even mechanically attached one with self-healing qualities will help sealing around those nails and just prolong the service life of the roof system without any leaks. In more severe climates, or when using adhered tile systems, such as the systems as pictured here, where you're using a roof tile adhesive to adhere the tiles down to the underlayment, a polymer-modified self-adhered underlayment is recommended. And one of the reasons is also because, this, as pictured here, this fabric top surface underlayment is ideal because it grips and bonds very well with this roof tile adhesive. So you have very good adhesion, and especially in terms of like extreme weather events, so you don't have blow-offs of tiles. For asphalt shingles, you have a variety of options for underlayments. You have everything, from organic felts to synthetic underlayments. Ice and water underlayments are typically those self-adhered polymer-modified underlayments, and they're commonly used with asphalt shingles, especially in critical areas along the eaves and rakes and valleys. And then sometimes code allows for, mechanically attached like organic felt installed in the field of the roof. But a growing trend has been to utilize the polymer-modified or synthetic self-adhered underlayment over the entire roof deck to offer that secondary water barrier to the entire structure, so to avoid water infiltrating in situations like this, where you have, in this case, a hurricane that blew off half of the roof covering, but you still have, you might be able to see that white area is that underlayment that's still protecting the property inside that home, so you don't have such severe damage. So speaking of that, is it beneficial to have underlayment just in those critical areas on the eaves and valleys and rakes, or is full coverage desired or required? So code often drives the answer to that question. In certain regions where ice damming or severe weather is common, it's actually mandated by code that the underlayment cover the entire roof deck, and it actually to seal the deck specifically. In some areas, code mandates, like I said before, just for those critical areas to have the self-adhered polymer, modified self-adhered underlayment. And in other regions where you have hurricane zones and other severe weather events, sometimes even 2 layers underlayment are necessary and mandated by code. So some of the disadvantages of going with a self-adhered underlayment over the entire deck and sealing the deck is obviously cost, because you're talking about a premium product being applied over the entire roof deck. So there's that disadvantage, and consideration must be given to ventilation, right? Because when you're using a self-adhered underlayment over the entire roof deck, it effectively acts as a vapor barrier. So sometimes you have to consider, do you have adequate attic ventilation? Or if not, you can install an anchor sheet on top of the roof deck before you install your self-adhered underlayment, so you kind of have additional ventilation so you don't have moisture trapped in the roof deck. Advantages are many here for going over the entire deck. We talked about providing a secondary water barrier and the advantages that can have in severe weather events. So you're really completely covered there with another layer of protection, in this case something that's dedicated specifically to waterproofing. It does provide a more bondable surface for certain adhered roof coverings. We looked at the tile, the adhesive set tiles, and how great that fabric surface underlayment works with the tile application. And you can actually enhance worker safety. Why? Because a lot of underlayments have grippy surfaces, embossed patterns on them that facilitate actually the contractor's work on the roof so that they don't slip and fall. They can work more efficiently without having any safety concerns. And with mechanically attached roof coverings, if you have a underlayment with self-healing qualities to it, it's going to prolong the life of your roofing system. In this last section, we'll discuss actually the importance of something called nail sealability. And nail really refers to any type of fastener, right? But it's commonly known in industry as nail sealability. And, a common guideline for fasteners, I discussed it a little bit earlier, is, don't overdrive, don't underdrive the fastener, don't fasten at an angle. But the reality is that you have hundreds, sometimes thousands of fasteners going into a roof deck, and it's really unrealistic to expect for every fastener to be installed properly. And even a properly installed fastener can leak, right? Water can leak through that, especially with wind-driven rain, ice damming conditions. And that's really the key with nail sealability, because if your underlayment has, because of the asphalt compound in it, that natural quality to seal around that nail, you have that additional protection in these cases. The self-adhered membranes also limit the movement around the fasteners due to foot traffic or other forces. And when you talk about mechanically attached roof coverings such as metal and tile and shingle, it's going to seal around those fasteners very nicely. And we already talked about the weather events, ice dam conditions, and other events where this is especially important. So in this short video, we'll actually demonstrate nail sealability using a modified version of the head of water test, which is an ASTM test, D7349, which actually is designed to test the sealability of an underlayment around a fastener when actually under water conditions, right? So here you have a roof deck, a plywood deck. It's a mock-up of a deck. And on the top side, you have a polymer-modified self-adhered underlayment with nail sealability qualities. And on the bottom, you have a synthetic underlayment with no nail sealability qualities. So 2 nails were driven into each underlayment and through the deck, and they were actually underdriven on purpose to simulate something that's commonly seen in the field. Light foot traffic was applied to that area to simulate the movement around the nail heads, and a 12 by 12 sample of the roof deck and underlayment were taken out from that deck and placed in these acrylic tanks with 2 chambers, a top chamber, bottom chamber, and water with food dye was placed in each chamber and was observed, right? On the left-hand side with the green water, you have a polymer modified self-adhered underlayment. On the right-hand side, you have a synthetic underlayment with that red-colored water. And before 72 hours had passed, you could already see water saturating the deck, and at the 72-hour mark around there, water actually started dripping through the fastener head or through the nails into the chamber below. In real-life conditions, this would have caused, over time, property damage, mold growth, and on the other side, you see the self-adhered underlayment, the polymer-modified self-adhered underlayment that even after days of exposure underwater, it had no leaks. So in summary, for the presentation, we covered quite a few things here. Roof coverings can leak from damage or improper installation, including flashing details, penetrations, and fasteners. A roof design must be chosen to suit local conditions, and building to minimum code standards may not always be adequate. Underlayments play a critical complementary role. With any roof covering, compatibility of underlayments with the roof covering should be considered. Roof leaks can be minimized through proper roof design and selection of secondary water barriers and utilizing correct installation techniques of the roof covering and the underlayment.